Video will continue our discussion of what a DE is, a DiffEq, differential equation. So with that, when we're talking about a solution and our solution is a function, right? Something, it is natural for us to then talk about an interval. What that means, okay, is that my solution, so let's look at this example actually. What it means is I need to find some kind of interval such that I can pick any x in that interval that I want and this thing exists. Now, I don't know, hopefully you guys remember your tangent functions, right? The normal tangent function looks something like this, and it had like asymptotes here and here. And this asymptote was pi over 2, and that one was negative pi over 2, right? That's this one and this one. Okay, if I move it around plus c, then I will have to move that interval around as well, because remember, if I take a function and I do that, it moves it opposite. So this would be, it would move it left, whatever c is, if it's a positive number, right? It's the opposite of whatever it may be. So it says verify, and then we won't actually talk about a solution on here because this causes an issue. We don't know what C is. We'll talk about that in the next section on how to figure out what that C stuff is. Okay, so they just want us to verify. They said this solution, right? This function is a solution to this diffeq, right? So it says first derivative equals 1 plus the function squared. So let's go ahead. I'm going to write down the function here. I like to write it down first before I put the derivative underneath, just to be neat. All right, so first derivative then, remember, derivative of tangent is secant squared. Chain rule derivative of x plus c is 1. So we just have those two. So they want us to verify, does secant squared x plus c, does that equal 1 plus y, which was tangent squared x plus c? Now, I don't know if some of you guys know that maybe right away. I'm going to go ahead and show you, like, because I don't have it memorized. I'm just like, oh, I think that's that thing. And then this is how I double check without a calculator. This is a Pythagorean triple, or sorry, Pythagorean identity. Pythagorean triples are like 3, 4, 5, stuff like that. So this is how I get to those. This is the only one I have memorized. I have a faint idea of the others. How I get to these is, to the other ones, is I think about dividing each one by sine or cosine. So to get, I'm gonna go through each one. I'm gonna show you. I'm gonna divide by sine. So if I divide every term by sine, sine squared over sine squared is a 1. Cosine squared over sine squared is a cotangent squared. And then 1 over sine squared is a cosecant squared, I believe. Yes. Okay, that's what the other one. And then there's 3 of them. The other one I can do it by dividing by cosine. So I go back up here. And sine divided by cosine is tangent squared. I'm dividing by squares. Cosine divided by cosine squared is 1. 1 divided by cosine squared is secant squared. And you can see that that identity verifies this. So it was a solution. That's it. So they're going to be a little bit more complicated than that. This we got lucky that literally as we plugged it in, it was a trig identity. All right, so let's start talking about that interval. Okay, that interval I was talking about where like we were saying that tangent functions like exist in between that and we want just one interval. This interval has several names. Interval of definition, interval existence, validity, and the domain of the solution. Many different names. They actually have different names with the application as well. Okay, so it can be an open interval. What that means, the open parentheses there, closed interval, meaning the inclusive, and then it can also be an infinite interval, right? It can be as long as everything in that interval can be defined in the function. So take a look here. Okay, so it says the function y equals x minus 2 over x is a solution of the DE. That which y of x is a solution of the first order. Find the largest interval I for which y of x is a solution of the first order diffeq. Okay, so first thing got to do, I think It didn't even tell us to verify. I'm going to verify just for practice here. So y equals x minus 2 over x. And let's go ahead and change the 2 over x to 2x to the negative 1. I would recommend for if you're in Calc 3 or DiffEq to go ahead and get fast at doing that derivative. So y prime then would be 1 plus, and it's going to be 2 over x squared. Right? You could think about that if you like negative 1 comes down, makes it positive, becomes a negative 2, that sends it back down. Right? So now we're going to plug this stuff in, x, y prime plus y, and we're wondering, is it going to be equal to 2x when we plug it in? So x times 1 plus 2 over x squared plus x minus 2 over x equals maybe 2x. And so what we're trying to verify here. All right, that distributes, so we get x plus 2 over x plus x minus 2 over x. That handles that 2 over x problem. Those are gone, and I get 2x. So 2x equals 2x. So we verified it. It didn't tell us to, but I wanted to do it. And then the interval I is going to be, okay, so we're looking here. If we take a look at this function, the domain of this function, I can plug whatever I want into that as long as it's not 0, right? So this is some kind of function that has a vertical asymptote, something like that maybe. It could be over here, who knows? I just know that I can't do the 0. So if it was like this, right, then the biggest interval that it would work on would be 0 to infinity. I could have also chosen negative infinity to 0, but not both, right? This is the largest interval, and really there's no difference in size between 0 to infinity and 0 to negative infinity. Infinities get weird when it comes to size, but we'll just try to always pick the positive one if it doesn't matter. All right, so there's I. So every time we're going to get to a point where you're going to solve it, find a solution, and then find the interval on which the solution will be defined. And very, very rarely I will have you graph them as well. That's really not my focus in this course. I want you to be able to solve the DiffEq. All right, so let's keep going forward here. So another way that a solution could pop up is it could be an explicit solution like we've been working with, or it could be what we call an implicit solution. And I know that probably rings a bell in your head, at least for the implicit differentiation. And I always ask my students this, and I'm hoping that it just becomes more common knowledge. Implicit is just meaning you can't solve for y, right? Or you could, but it's not really pretty, right? It would be very difficult. So take a look here. The relation, that's a circle with radius 4, right? At 2, 2, is an implicit solution of the DiffEq on the open interval. Now, I could take this and solve for y, and what I'm going to get is I'm going to get this plus or minus in my answer, two answers, or I could just leave it, sorry about that, leave it the way that it is. Now, I could solve. I'm going to show you how I would get about to this. I'm going to do this here. You're going to have to write kind of small. I forgot to put a space here. Um, we start by just taking the derivative. So let's go ahead and do that. We get 2 times x minus 2 to the first power. Chain rule would just times by a 1 for the derivative. And then I do the same thing for y, 2 times y minus 2 to the first derivative. But remember for y's, I got to times by that dy dx. And then the right side is just a 0. So now what I'm going to do, this is what we did in Calc 1, is we would solve for dy dx. Okay, so I'm going to write 2 times y minus 2 times dy dx equals negative 2 times x minus 2. And then I'm going to solve by dividing dy dx. The 2's are gone, and I get this negative x minus 2 over y minus 2. Well, if you notice, if I were to distribute that negative and flip it around, we get 2 minus x, right? The x is going to be negative now, over y minus 2, which is that. We verified it. All right, and then it says on the open interval, let's actually, I think, -5, -5 to 5. I think this is off just a bit. Let's go ahead and fix this. I want you, if it's not already fixed in your notes, this is defined. It's not going to be -5 to 5 because this is at 2, 2, right? There's my circle. And it goes 5 in each, 4 in each direction. 2, 3, 4. So it's right there. Or 1, 2, 3, 4. So, and then 1, 2, 3, 4. So it actually goes from 1, 2, 3, 4, -2 to 2, 3, 4, 5, 6. So it's -2 to 6. I think I may have stole that from another example. All right. The reason it's that is the domain of that function, right? Okay, solution curves. Now we're going to verify again. And then they gave us the interval, and you'll see you can tell by our solution, there's nothing weird there. I can plug whatever I want into x. I can plug whatever I want into cosine of x. I'm not dividing by anything, no square roots, no ln's, no logs, nothing that's going to throw it off. So I got to verify it. And then we got to find 5 particular solutions and graph the solution curves. And I'll tell you what that's a new definition there. It's not a hard one. I'll tell you what it is when we get there. Okay, so we want to verify this. So let's go ahead. I'm going to write down the function. I just like to do that to wrap my head around the problem. And I know by the diffeq given to me, I just need the first derivative. All right, we get c minus, okay, c is just a constant. And then don't forget, this is a product rule. I'm going to write out the rule. I've gotten that habit in Calc 3 because partials, I mean, they're not bad, but I was messing it up. So I started writing out my rules. And I know a lot of you guys don't want to, but if you keep messing it up, then you probably should, right? Okay, so there's that. I'm going to go ahead now and rewrite it, simplify it. I'm going to get c minus cosine of x because derivative of x is 1. And then the derivative of cosine is a negative sign. So I'm going to get x times sine x. I like to write the rule out because then it was literally right in front of my face. I didn't have to like juggle it in my head. All right. So now I'm going to go ahead and make sure that works out to be this side. So let's go ahead and do x times y prime minus y. And we could do another way that we could write this out is we're going to write left-hand side. If you're just wanting to write out one side, work it out and see if it matches. You write left-hand side there and work it out. That would be a great way. If not, keep your equal sign, keep the x squared sine x. Remember, you have to communicate this correctly. All this stuff matters on how you're labeling it. All right, x times, okay, y prime is going to be c minus cosine x minus x times sine x, and then minus cx minus x cosine x. Okay, let's see what we can get. If I distribute, okay, I get cx cosine x minus x squared sine x, and then minus cx minus x cosine x, right? All right, I don't see what's gonna go away. Okay, I think we ran into maybe an issue. So something that's come out of here, maybe I messed up. So C minus, here it is. All right, so this is fine. I'll leave it in the video. It's like gonna re-record, but the thing that came out of here, some of you guys were probably yelling it at me in the video. That makes a negative, but this thing here is gonna make it also a positive. Leave it to a sign error. But what does that change here? That becomes positive. This becomes positive. Now, why doesn't do the other things go away? Well, let's see. This is why we want to write our things nicely. Perfect example. Right, look, this is that was a minus there. Glad we found it. Cool. Um, this class, I actually struggle with it sometimes because of that. You got to be able to read your own handwriting. Right, there we go. This goes away with that. And then there's some negative problem somewhere in here. Okay, was that supposed to be at the end there? Minus y, minus, this becomes a positive. That goes away with that, and we're left with x squared times sine x. Okay, there we go. It checked out. All right, so be careful with that. Forgive my arithmetic mistake. Literally, I think one negative, two negatives threw the whole thing off. So be careful with that. With this negative here, maybe I should have kept the negative with the x there or something. Maybe I wouldn't have made that mistake. Okay, so let's finish the problem though. It says five particular solutions. So this is my solution, cx minus x cosine x. So we're literally just picking c's. All right, so we're gonna do y equals minus x cosine x. I'm gonna do that c equals 0. And what we're gonna do for graphing is we're just gonna take a look at them. So I'm gonna go ahead and pick 5. And then we're going to put them in the calculator. And I'm going to be extremely boring and go up. Let's double them. So this is going to be 2x minus x cosine x. I know I didn't double the first one, but I guess I did. No, 0, then 1, then doubled. Okay. 1 equals 4x minus x cosine x. And then y equals 8x minus x cosine x. All right. If you want to draw it in your notes, you can. I think we're just going to look at the calculator and uh, take a look and see what it looks like. Actually, Desmos may be a good idea here. Do I have Desmos as an app? I think I do. I just think it was right there. I thought I saw it. Desmos. Don't know why I did that. Sorry, you're having to watch an old man use apps. All right, let that download. Cool. This will be better to look at. Okay. So let's type in the first one we'll do is y equals minus x, and then I need cosine, uh, s- and then back to x. Okay, cool. And then actually, let's go ahead and just take a look at it like this. We're gonna put a c here, c x, and then add a slider. Now we can take a look at it. So take a look at the solutions. It's going to start at C of 1, and I'm just going to have it go through negative 10 to 10 so we can see what happens with the solutions. See, it's pretty crazy actually. So if like C is 0, let's take a look. This is C is 0, we get it right there in the middle. So what is C doing then? If I go up by 1, let's go just nice pretty 1. Interesting. It's kind of neat because it's all hitting that like axis there. So it's making me wonder, I mean, is there y equals x, does it play a part, you know? And then put 2. See there, so 2x, y equals 2x. I'm wondering if there's some kind of connection there between the slope of what that line is moving and what we have chosen. Because it looks like, okay, let's put a negative number. Yeah, it just flips it. Yeah, so looks like it's like moving it along some kind of line there. It's kind of neat. All right, so back to here. There's our 5 solutions. These are what are called particular solutions, meaning like the C creates a family of solutions up here. That's a family of solutions because I could just pick a bunch of C's and come up with like I just did down below. And then these are called particular solutions because it's one solution, right? It's not a family, it's not a bunch. The C was told. What we're going to do in the next section when we get there is we're going to start giving it a point that it goes through, and then we'll be able to, given a point that it goes through, we'll be able to find a C to find a particular solution.